Welcome to the lecture to Introduction to Object-Oriented Programming. There are many programming languages that support objects. For example, Java, Python, C++, JavaScript, Ruby, and many other ones. There are also some of the other older languages that do not support objects, like Assembler, C, Fortran, COBOL, etc. The important thing about it is that just because a programming language supports object-oriented, it doesn't mean that writing any code in that language is by default going to be object-oriented programming. Object-oriented programming is a practice in software design. So what we are going to learn in this course is the practice of object-oriented programming. The goal for this course is not to get your code to run, is not to have a functional code, but is to learn how to design a program following the principles of object-oriented programming. So let's see what's the difference between functional programming and object-oriented programming. In functional programming, we are building software by composing pure functions, avoiding shared state, mutable data, and side effects. Functional programming is only focused on getting a functional code down. And it can be done in any language. It can be done in an object-oriented programming language. But that is not what we are doing here, and this is not our goal for this class. For this class, our goal is object-oriented design, to learn how to design following the object-oriented programming principles. And we want to code in a way that is not functional programming. Now let's see what is software engineering. It's the application of a systematic, disciplined, quantifiable approach to the development, operation, and maintenance of software. That is, the application of engineering to software. How about computer science? Computer science is a broad discipline that A. Studies the necessary mathematical and scientific theory required to create correct and efficient algorithms for manipulating information, and B. Designs and develops systems that implement the algorithms in A. How about engineering? Engineering is the systematic application of scientific knowledge in creating and building cost-effective solutions to practical problems in the service of mankind. Are we engineers? Well, in this course, we are trying to be engineers. We want to design systems that are comprised of objects that interact with each other. That is the way that object-oriented programming works. That's the way that we want to build our softwares. What are principles? In software engineering, following the principles is key. Design is fundamental for a good and practical and effective application. Coding is given. We assume that everybody knows how to code. What we are focusing on is the quality of that code, is the quality of the design of the program that we are coding. So in this lecture, I'm going to go over basic object-oriented concepts, and those are classes, inheritance, abstract classes, interfaces, polymorphism, encapsulation, cohesion, and coupling. So I will go over each of them one by one and explain them to you. Classes in Java are representations of an object, and they have names. So each class comes with a name. A class has one or more than one constructors that is used to create that object. Class have fields that hold the data about that object. They also have methods that define the behaviors of the class. And they also have accessors, or what we call getters and setters. In this course, we are not going to make getters and setters for every single field that we have. We think about it during the design process, and we only use getters and setters for the fields that we are going to need getters and setters for. So by default, we are not using getters and setters. We only use them whenever we need them inside the class. Visibility in Java refers to how accessible each of the objects are inside the program. We have different levels of visibility in Java. We have private, which means that that object is only visible within the class. We have default or not specified, and that means that that object is package private, only visible for classes in the same package. We have protected, which means that the object is visible for the whole package plus any subclasses. And we also have public visibility, which means that that object is visible from anywhere in the code. We only make things as visible as they have to be for the system to work. So we start with private, and then we consider if we want to bring more visibility to any certain object. So by default, we are going to set all of our objects as private. Classes are blueprints that tell us how an object should look like a cookie cutter. You can use a cookie cutter to make any amount of cookies. You can use the blueprint to make any amount of instances of a class. Now, let's talk about inheritance. So, classes can inherit from each other, and that means that they can acquire the properties and methods of another class. In this case, one class will be a superclass or a parent class, and another one would be a subclass or a child class. And these classes can have an is a relationship. For example, we can have a parent class called doctor, and we can have a child class called surgeon. Surgeon is a specific type of doctor, and it acquires all the properties and methods from the class doctor. Subclasses inherit constructors, fields, and methods from their parent class. All of those can be used as if declared locally. Subclasses can override inherited methods, so they can implement their own behavior in those methods, making the subclass unique. We should also remember that the inheritance is one way. It's only the subclass or the child class that inherits from the parent class. It's not the other way. The levels of inheritance can be infinite. So, for example, we can have an executive that is a type of manager that is a type of employee. And this can be as long as we want it to be. It all depends on our design. To look at an example, the way that we coded in Java is to use the keyword extends. So for example, in this code, when I say public class square extends rectangle, it means that square is inheriting from the rectangle. So a square is a rectangle. Pay attention that in this instance, rectangle is a real class. We can create a rectangle and we can create a square. We also have a keyword final. That keyword, if used, means that that class cannot be extended. For example, we can make square a final class so no other class can inherit from it. We should also pay attention that Java allows for single inheritance, and that means that a class can only extend one other class and no more. What is abstraction? It is representing essential features without including the background details or explanations. In Java, we have two different types of abstractions: interfaces and abstract classes. And I'm going to talk about each of those. But for example, if you want to look at an example of an abstraction, we can have a class that is called fruit, and that could be our parent class, and that's just an abstract idea. So for example, if you go to a store and ask to get a fruit, you need to be specific about what kind of fruit you want. Do you want an apple? Do you want an orange? Do you want a banana? Each of those can be children of the parent class fruit, and they can be a real fruit. They can be a real object. But fruit is just an abstract idea of all of those other fruits that we have. Similarly, for bank account, you need to specify if it's a checking account or a savings account. But we know that all of those are eventually a bank account. So here, bank account is an abstract idea of an account inside a bank, and then you can have children classes that define what type of bank account they exactly are. Let's have a look at an example of an abstract class. Abstract classes are classes that cannot be instantiated. They can only be subclass, and they use the keyword abstract. So for example, we can write the code for the fruit class like this: abstract public class fruit. Also, when a class wants to inherit from an abstract class, we use the keyword extends, and it would look like public class apple extends fruit. We also have interfaces in Java, which are similar to abstract classes, but they cannot be created. They use the keyword interface. So for example, in this example, we have public interface bank account. To access them, we use the keyword implements. For example, we can define a checking account class by saying public class checking account implements bank account. It does not have a limit like extends. So we can have many classes that implement one interface, opposed to inheriting when, when a class can only inherit from one other class. So as we said, interfaces are just a more limited version of an abstract class. And you can see the differences here. Let's have a look at an example of an abstract class. We have abstract public class fruit. We have a final variable fruit, and the value inside is also fruit. And we have an integer variable named size. The constructor fruit gives the size and sets the parameter that is getting from the constructor, and puts the value inside the variable size in the class. We also have a getter for getting the size of the fruit. And we also have an abstract method called isEdible, and that tells us that any class that extends fruit should have a method called isEdible. This is an example of an interface. Public interface bank account. We have a string variable called bank, and we also have a final variable called account. There is a method of type void that is called print. So that tells us that any class that implements bank account should have a method called print. We also have another method called do stuff of type void, and it just prints something. And you can have another method here that does something differently. So it's important to know that bank and account are constants. Do other stuff is a public method. Print is also public, but it's not default. So we have different levels of visibility here inside this interface. Picking between abstract classes and interfaces can be tricky, but there are some guidelines for you to help you make that design decision. One of the important things that you need to ask yourself is that should the parent be created? That's to decide whether you need to use abstraction or not. So if the parent is an object that needs to be created, you should use a regular class, not an abstraction. If the parent is a class that is just an idea and is not a real object and is not going to be created, then you should use abstraction. Now, when you want to use abstraction, you should ask the following questions. If you have common constructors, if you have common fields, or if you have common method implementations that should be protected instead of public, you should use an abstract class because we cannot have those in interfaces because of their limitations. Otherwise, we can use interfaces because they're more direct at the functionality that they provide. And if we do not need those extra functionalities that abstract classes are providing, the better choice, the better design choice is to use an interface. Another concept in object oriented programming is polymorphism, which is a Greek word for having multiple forms. It means that similar objects can behave differently. This is one of the largest advantages of object oriented programming. So, for example, we can have a parent class, animal, and we can have children classes, pig and dog. Both pig and dog are an animal, and for being an animal, they share some common fields and behaviors. This helps our design to be more solid and also helps us have different layers of common behaviors and fields that we can associate to different objects. This makes us as designers more powerful through giving us the power of polymorphism, that something can be two things at a time. A dog can be a dog, but also can be an animal. In this case, I can have an instance of an animal and later on decide that whether I want it to be a pig or a dog. That gives us more power as designers in object oriented programming. Encapsulation. It means hiding as many details as possible. What we want to do is to make each object a black box. Anyone who isn't a developer doesn't need to know what's happening inside the box. They just need to be able to give it some input and get the required output. And we can do that through different levels of visibility that Java gives us. So we can start making everything private and then work up if needed. We can make something public if we need to. But to get there, we need to go from private to default to protected. We need to evaluate what type of visibility we want to give to each object. If it's not necessary for it to be public, we're not going to make that public. It's only going to be inside its own class, and no one else can have access to it. That is encapsulation in object oriented programming. Next, we have cohesion. It means that tasks in a single module are related. So what it means that, for example, inside the class, we want to make sure that all the fields and methods are related to each other and are serving a very specific and small purpose. What we want to have in our programming is high cohesion, which means that all the modules are very related or closely related to each other. If we have low cohesion, it means that we have a lot of parameters and a lot of methods inside the class that are not necessarily related to each other. That is bad design. We also have coupling, which means interdependence between the modules. How many parameters does your constructor need? How many parameters does your method take in? If you have too many, it is bad design. You want to have the least possible number of parameters inside a class, inside a method. That means that you depend on less parameters, on less methods for getting a job done, and that is good. If you have high coupling, that is a bad design practice. So you want to keep that in mind. And finally, we want to talk about Java naming conventions. So for classes, we use Pascal case. So the first letter of each word is uppercase. For variable names and method names, we use camel case. So the first word is all lower letters, and from the second word, only the first letter is uppercase. And we don't use numbers. We spell out the numbers if we want to have numbers in the name. We do not use actual numbers in the name. Constant names are all caps separated by underscore. And for all of our tests, we do all lowercase separated by an underscore.